This is GATE 2017 set 2 ECE question number 24. It says that two conducting spheres S1 and S2 of radius A and B, where B is greater than A respectively, are placed far apart and connected by a long thin conducting wire as shown in the figure. So this is S1 and this is S2, and S2 is having a radius B. The small one S1 is having a radius A, and they are placed long apart and connected by a thin wire. So now, for some charge that is placed on a structure, and the potential and surface electric field are respectively given for S1 to be V1 and VA, and S2 that is with radius B to be VB, and respectively, then we are being asked to comment about their potentials, respective potentials of the two spheres, the relationship, whether they are equal, greater than or less than, as well as the relationship between the electric fields of the two respective spheres. Now, in order to solve this question, we need to know that for a conducting sphere, as is given in the question, both the spheres are conducting. So we must know that for some charge, as is given in the question, some charge is placed on the structure. So for some charge placed on structure which is conducting itself, so conducting, now connected by wire, then as you know, let's say this is a battery and this is another battery. If you both are 5 volts, no charge will flow, that is no current will flow. But if there is a potential difference, charge will continue to flow until and unless both the potential becomes equal. The same things happens. Then charge, what is happen, will flow and continue to flow till redistribution takes place. Okay, and their potential becomes equal. So this is a very important point. So potential becomes equal until and unless that it is equal. So since they are connected by that long wire, so charge Q1 and charge Q2, and they are connected, all are conducting, charge will continue to flow till VA equal to VB. So if this is A and this is B of radius, then VA equal to VB. That must happen since it is connected by wire and both are conducting. So coming to the solution, as we understand, VA must be equal to VB. Now drawing the diagram once again, this is of radius B and this is of radius A, and this is S1 and this is S2, and is connected by a wire. This is the wire and all are conducting. So R2 equal to B and A is R1. Now all are conducting, please note, and charge distribution, for example, has taken place, and Q2 and Q1 are their charges. So VA must be equal to VB. This is the answer. And now we know that what is VA. VA is 1 by 4 pi epsilon naught, the charge on A, that is Q1, by the radius of A, that is A, that is sphere 1 radius is A. Now for sphere 2, the radius is B, so Q2 by B, and B is greater than A, as you see from the diagram and it's given in the question. So now 1 by 4 pi epsilon naught and 1 by 4 pi epsilon would cancel, and implementing this relationship we get Q1 by A equal to Q2 by B, implies that Q1 by Q2 equal to A by B. Now the electric field of A, there is a surface electric field. So surface electric field for S1 with radius A is given by 1 by 4 pi epsilon naught q by r square. So q is q1 divided by a square. So similarly this is e1, or you can say ea is this. So similarly ev, there is a surface charge of b of sphere s2 of radius b is e2 equal to 1 by 4 pi I epsilon naught q2 by b square. So e1 by e2 is q1 by q2, right, b square by a square, and we know q1 by q2 is a by b. So equal to a by b into b square by a square equal to a by b, so b by a. So e1 by e2 is b by a, where b is greater than a, implies that e1 b is greater than a, so e1 is greater than e2, right? So b is greater than a, so e1 must be greater than e2. Hence we get this relationship, e1 must be greater than e2. So e1 means the electric field of sphere 1 whose radius is a, the smaller one, its electric field e1, its electric field e2, the bigger one. So e1 is greater than e2. We are getting this relationship. So we can also say ea, that is sphere with radius a, greater than ev, right? Same thing. So because we are in given in ea ev terms, so that is the answer. So ea must be greater than ev and va equal to vb. So answer is option C. Option C is correct.